Hello, good morning. So today we are discussing a problem on our runge kutta method. Okay, so shall we start it? So the problem is a three-phase fault occurs at the end of line 2. So this is line 1 and this is line 2. So three-phase fault occurs at the end of line 2 near the bus 2. So this is our bus 2. So a fault occurred here as shown in the figure and is cleared by isolating the faulted circuit simultaneously. Generator is delivering 1 per unit power at unity power factor. The fault is cleared in 0.1 second. Obtain the numerical solution of the swing equation up to 0.5 second using runge kutta method, and we have given delta t is equal to 0.05 seconds. So first we have to find out the steady state value, that is 0.0 value. Okay, then we have to find it out for 0.05 second, then we have to find it out for 0.1 second, and then we have to find out for 0.15 second. Okay, we have to find out for 0. So what we have to do is we have to find out the value for 0.15 second. Okay, now what we have to do is first I have the algorithm with me. First we have to calculate this. We need P max value, isn't it? For this P max, E and V are always constant. So first we have to find out E value and V value in the circuit. Then we have to find out x0, x1, x2, or we have to find out the accelerating power for pre-fault condition, faulted condition and post-fault condition. Then after that we are assuming first for pre-fault condition we are taking delta t is equal to 0.05 as given in the question. And we will solve for K1, K2, K3, K4, L1, L2, L3, L4. Then we will get delta 1 and omega 1. So using this delta 1 and omega 1, we are calculating our faulted condition. Okay, and when the faulted condition, again we have to find out this. We use this P max 1 and we have repeat the iteration from this step onwards. Then we have to continue for the post fault condition. So this is the following steps we are going to do. Okay, so what is the first step? First step, I have to find out the value of E and V and all those things. So first I am writing what are the parameters given, that is the generator is delivering 1 per unit of power at unity power factor. So it is given that P is equal to 1 per unit and unity power factor, so Q is equal to 0. Okay, so if I am writing my apparent power, S is equal to P plus JQ is equal to V into I conjugate, isn't it? So I have to find out my current. I is equal to P minus JQ divided by V conjugate. What is P? P value is 1 minus J value is 0 divided by V conjugate. What is V conjugate? It is given delivering V value. It is given as 1 angle 0, isn't it? So because the generator is delivering 1 per unit power, so V value is 1 angle 0 and we will get the current. What is the current? The current is also 1 angle 0 degree. So we got 0 degree. No, we have to do it in radian. So I'm not taking in degree, it is radian, 1 angle 0. Then what is the we have to find out this E value. We have to find out E value and we have to find out the V value here. So here it is given as 1 angle 0, isn't it? Then what we have to do, we have to find out the value here. If I am redrawing my circuit, then it will be, if I am redrawing my circuit, then it will be like this. There is an reactor that is J 0.6, then first bus, then there is another bus that is J 0.2, then we have two other values, that is J 0.5 and J 0.5. This is our equivalent circuit I have drawn. Okay, and we have some other, it is connected to infinite bus bar. Okay, so we got the current value as 1 angle 0. We got the current value as 1 angle 0. So here it is, E is 1, here it is 1 angle 0 degree. Current is also 1 angle 0 degree. Then what is the voltage here? That is E value will be equal to this 1 angle 0, 1 angle, not in degree, radian, 1 angle 0 plus the potential drop here, isn't it? Because this value E minus potential of this will give 1 angle 0. So E is equal to 1 angle 0 plus J 0.6 into 1 angle 0. So what will be the value? That we have to find out. Okay, so what will be it? I have to move to complex mode, then 0.6 shift I. That is 0.6, then plus 1 shift angle 0 is equal to, that value will be equal to 1 plus J 0.6, isn't it? So if I am converting it into my polar form for my easiness, okay, I have done. So I can write it as 1.166 angle 0.540, angle 0.540, 0.54, or what I can write, okay, this I got it as my E value. This value I have got. Now we have to calculate what is the V value. Okay, so what is this V value? This value will be the current flowing through it is 1 angle 0. So if I am finding out my voltage value here, that V value is equal to, what is the value here? 1 angle 0 minus the potential drop here. So the total impedance is 0.5, parallel 0.5 is a R by 2, isn't it? So 0.25 plus 0.2 is 0.45. So I can write it as J 0.45 into 1 angle 0. So what is it? Minus 0.45 I plus 1. I got it as, then I am converting it into radian mode, that is 1.096, 1.096, 1.096. What is the angle? It is minus 0.42 is equal to angle minus 0.42 radian, isn't it? So I got my E value and V value. What is this load? What is this angle delta? Delta is the difference between these two values. This is the voltage angle, and this is also, E is the voltage, V is also voltage. So in order to find out delta value, we can say it as E value minus this V value. So 0.54 minus 0.42, you will get it as 0.54 plus 0.42, you will get it at 0.96. So 0.96. Okay, so while solving this, we used to write, here it is infinite bus, so we used to write V angle 0, but here we used to write it as E angle delta, isn't it? That value we got it here. Okay, so I am rewriting all the parameters I have got for my calculation. So I have got my values as E value is equal to E angle delta is 1.662, and also V angle 0 is V value, that is 1 angle 0. Okay. Then now what we have to do, in the first step I have calculated E and V. Next I have to find out x0, x1, x2. That is, I have to, in my step 2, I have to find out my this electrical power, isn't it? So PA, or the varying value. Okay, PA, or I should write PE. PE 0. PE 0 is under steady state condition or pre-fault condition. PE 0 is equal to, we have to find out P max 0 sine delta 0. P max 0 sine delta 0. What was P max 0 under pre-fault condition? We have to find out, or I can write it as EV by x0 into sine delta 0. What is x0? Under pre-fault condition, there is a 0.6. Then there is a transformer. What was the transformer reactance? It is given as 0.2. J 0.2. Then there are two best values, that is 0.5, J 0.5, J 0.5. So if I am simplifying it, then J 0.5 and J 0.5 in parallel, that is J 0.25 plus J 0.2 is J 0.45 plus our 0.6 is plus our 0.6 is J 1.05, isn't it? So I can write it as J, x0 value is equal to 0.2, 0.8, 1.05, 0.6, 0.8, 1.05. That value is correct. Now what we have to solve is, we have to find out what is E value. E value is 1.166 into V value is 1 divided by x0 value is 1.05 into sine, what is delta value? Delta 0, it was 0.96, isn't it? So sine of 0.96, that we have to solve. Okay, sine of 0.96 value, I got it, into 1.166 divided by 1.05. So that value is 0.909. Once again I am calculating 1.166. 2, I am writing this 2 also. 2 into 1 into sine 0.96 divided by 1.05. That value is equal to 0.9098. 0.9098. Okay. So what is this? This is PE0, steady state power, that is 0.9098. Then this is our PE0 for steady state value. Now I have to find out PE1, that is the electrical power under the faulted condition, So what happened? A fault occurs here, isn't it? So what happened when a fault occurs here? My switch gears, all the relays here senses, and it will isolate this entire bus bar. Okay, so then what will be PE value? Then I can say PE1 value will be equal to 0. So there is no power transfer from here to here. So at that time PE1 value is equal to 0. Now what is we have to find out? We have to find out the post fault condition. What is the post fault condition? We have to find out PE2. PE2 is our post fault condition. Fault condition. So when post fault condition, what happens? I am redrawing it again. So there is a reactance, then this is my transformer, and these are my two buses. So what happens under post fault condition? This is my infinite bus bar. This is my bus 2 where fault occurs. This circuit breaker acts and this section, this entire line is isolated. So what will be the resultant value? That is J 0.6, J 0.2 and J 0.5. So PE2 is equal to the current flows in this direction. So PE2 value will be equal to EV by x2 post fault condition into sine delta, that is equal to E value is 1.1662 into V value is 1 divided by what is x2. x2 is 0.5 plus 0.2 is 0.7. 0.7, that is J 1.3 sine delta. PE2 value is J 1.3 sine delta. So if I am solving this, then I will get 1.1622 into 1 divided by 1.3. What is it? 0.894. Okay, so I can write it as 0.894 sine delta. So I got my PE2 value as 0.894 sine delta. Okay, so in this first step what I have done, I have calculated E and V value. In the second step I have calculated PE, that is electrical power output for the pre-fault condition, fault condition and post-fault condition. So pre-fault value I got it as 0.908. Under the fault the power transfer was 0, and after the fault it is 0.894 into sine delta. Next, what is our third step? Third step, we have to assume the iteration value k. Okay, so in the third step, what I have to do is I have to assume k is 0, that is pre-fault condition. And what is the delta t value? The delta t value will be equal to 0.05. Isn't it given in the question? Yes, it is already given us delta t is equal to 0.05. Delta t value is equal to 0.05 second. So what I have to do is we have to find out this K1, K2, K3, K4, L1, L2, L3, L4 in our next step. So delta t value is 0.05. Then what all things are given in the question? In the question we have found out that E value we don't require it. Delta value is equal to 0.96. So it is not delta 0 value, and it is in radian. Now what all things we have to find out is we have to find out our equation, isn't it? What was our equation? F of x y z. Instead of f of x y z, our equation was d delta by dt. First equation, d delta by dt is equal to what was it? Omega r minus 2 pi f0. Omega r minus 2 pi f0. That was our first equation. And we have our second equation, that is corresponding to g of x, y, z. We had d omega by dt is equal to pi f by h into P steady state power minus P max 0 sine delta 0. This was our second equation. So what we have to do is we have to substitute the values in these two equations, and we have to find out and we have to find out our K1, K2, K3, K4. Similarly, L1, L2, L3, L4, etc. Now, and we have to substitute in our equation to find out the next values for delta. Okay, now I am taking my iteration is equal to 0. Then what is the value of my K1? K1 value will be H into, that is delta T into F of T0 delta 0 omega 0. This was our equation, that is delta T value is 0.05 into what is this f of value. That f of value is here, isn't it, first function. So omega r minus 2 pi f0. So omega r becomes omega 0. So omega 0 minus omega 0, the value is equal to 0. So K1 value is equal to 0, which we have already ensured during our last class. So K1 value is 0. Now we have to find out L1. L1 is delta T into another function of T0 delta 0 omega 0. That value will be equal to 0.05 into what was our equation, that is pi f by h. Our equation was pi f by h, that f is steady state or f0, or I can call it as f steady state frequency, by h into steady state power minus our electrical power, that is PE0. What is PE0? Minus PE0, or I can write it as is equal to 0.05 into pi f steady state frequency divided by h into steady state power minus, what is steady state power, minus P max 0 sine delta 0. So what was the equation now? That is 0.05 into pi into what is Fs? F0 value. F0 value, it is our frequency is 50 divided by what is h value? It is given in the question as 4 into what is steady state power? It was delivering 1 per unit. 1 minus what is P max 0? P max 0 value we have already found out, isn't it? What is P max 0 value? P max 0 P max 0 value, it is under pre-fault condition, that is 0, no, that is PE0 value is 0.9098, isn't it? What is PE0? PE0 value, I have got it as P max 0 sine delta 0 value, I got it as sine delta 0, that is 0.9098 value. Okay, 0.9098, and what we will get our value? Our value we got it as 0.05 into pi into 50 into 1 minus 0.9098 divided by 4, that is equal to 0.177. Okay, so L1 value is 0.177. Shall I recheck it? That is 0.05 into pi into 50 into 1 minus 0.9098, that value P max 0. Sine delta 0 I got it, no? So divided by 4 is equal to 0.177. So L1 value I got it as 0.177. Now what is the value I got? Now K1, L1. Now we have to find out K2. What is K2 value? K2 value is equal to delta T into f of T0 plus delta T by 2, then delta 0 plus K1 by 2, and omega 0 plus L1 by 2. If I am substituting it, then I got 0.05 into f of omega 0. What is omega 0? That is omega 0 plus L1 by 2. So what is omega 0? Omega 0 value I haven't found out, isn't it? So we have to find out omega 0 value. Omega 0 is equal to 2 pi f0, isn't it? So 2 pi f0 value. What is 2 pi f0? Omega 0 is equal to 2 pi f0 value, that is equal to 2 into pi into f0 is 50 hertz. So 100 pi is equal to 3.314. Okay, it is not 3 point, but it is 314. 2 pi f0 value is equal to 314.16. So is equal to 314.16 omega 0. So what I have to do, I have to substitute omega 0 plus omega 0 plus L1 by 2. What is omega 0 value? That is 3 minus 2 pi f0, that is omega 0. So I can write it as 314.16 omega 0 plus what is L1, 0.177 by 2 minus 314.16, that is the value. So that is equal to what is it, 314.16 plus 0.177 divided by 2 minus 314.16 into 0.05. So that value is very less value, isn't it? K2 value is, oh, I am getting very less value. I am getting it as almost 0.00. I am getting it as 0.00442 value. I am getting the value like this. And I am finding out I have K1, L1, now K2. After K2 I have to find out L2. What is L2? L2 value will be delta 2, that is